We're going to talk about metallic characteristics and their trends within the periodic table. Metals are a set of elements with particular characteristics. Metals are known for their high luster or shininess, as you can see in this image of gallium. They are also known to be good electric conductors, such as copper. In addition, metals can be hammered into thin sheets, a property known as malleability, and they can be drawn into thin wire, a property known as ductility, as you can see in the copper wire. Metals bond with metallic bonding, in which a sea of electrons is shared among the atoms. This is what allows for such high electrical conductivity. Atoms of metal elements can move with respect to one another, which covalent compounds cannot do. Lastly, metals are all solid at room temperature, with the exception of mercury, which we can see here.
Metallic character follows certain trends within the periodic table. The most metallic elements are located in the bottom left of the table, and the least metallic elements are located in the upper right. This is because metallic trends decrease from left to right across a period and increase from top to bottom within a group. The alkali metals are located in group 1, and the alkaline earth metals are located in group 2. The transition metals are from group 3 to 12. The stair step represents a transition from metal to nonmetal, and the metalloids are located around the stair step. The nonmetals are located from group 13 to 18 in the upper right-hand corner.
Group 1 and 2 metals. The group 1 metals are known as the alkali metals, with the exception of hydrogen, which is a nonmetal. The group 1 metals consist of lithium, sodium, potassium, rubidium, cesium, and francium. All of the alkali metals are similar in that they have one valence electron in their outer electron shell, and that they are more willing to get rid of it, which makes them very reactive. The elements get more reactive as you go down the group. They are also known to tarnish easily and have quite low melting points and densities. They are usually silver colored, except for cesium, which has a slightly goldish tint. Alkali metals react with water to yield alkali hydroxides and hydrogen gas, and they react aggressively with the halogens, also known as the fluorine group, which we will talk about later, and they form ionic salts with them. Alkaline earth metals are the group 2 metals. They have 2 electrons in their outer shell and are quite reactive, but not as much as the alkali metals. They are sometimes shiny and soft, but again, not to the extent of the alkali metals. In addition, the alkaline earth metals burn in bright colors and are used in fireworks. Similar to alkalis, group 2 metals also have low electronegativities. Alkaline earth metals include beryllium, calcium, magnesium, strontium, barium, and radium.
The middle section of the periodic table from group 3 to 12 consists of 38 elements known as the transition metals, which are located in the D block of the periodic table. Like all metals, the transition metals are both ductile and malleable. They are able to conduct heat and electricity. Their valence electrons are present in more than one shell, which allows them to exhibit several different oxidation states or charges. Iron, cobalt, and nickel are notable transition metals because they are the only elements that are able to produce a magnetic field.
Metalloids. The metalloids are the group of elements that represent the transition from metals to nonmetals, and they are located along the stair step of the periodic table. This group consists of the elements boron, silicon, germanium, arsenic, antimony, tellurium, and polonium. The metalloids have ionization energies and electronegativities in between those of the metals and nonmetals, so they exhibit characteristics of both the larger groups. For example, silicon has luster like a metal, but it is brittle and an inefficient conductor, like a nonmetal. As a whole, metalloids are known to be semiconductors, which makes them very useful in technological devices, like in a computer. Other properties such as boiling/melting points and densities vary greatly among those under the metalloid category.
The nonmetals are located in the right of the periodic table and consist of the noble gases, group 18, the halogens, group 17, and the elements above the stairstep in the carbon, nitrogen, and oxygen groups from 14 through 16. Hydrogen is also a nonmetal. These elements are generally poor conductors of heat and electricity. They tend to form acidic oxides, whereas metals tend to form basic oxides. When nonmetals are in the solid form, they tend to be dull and brittle, in contrast to metals which are malleable, ductile, and lustrous. They generally have lower densities than metals, as well as lower melting and boiling points. They also have high electronegativity, as electronegativity increases to the right of the periodic table. This allows nonmetals to attract electrons to themselves. In conclusion, there are many properties of elements that are based on metallic characteristics. The most metallic elements are found in the lower left of the periodic table, and the least metallic elements are found in the upper right.